All right, hello everybody. Happy Thursday. As I had said yesterday and even earlier in the week, I am not able to be there today. I am busy at sectionals with the girls bowling team, which we are very excited about. Very nice. By now, you have hopefully already worked on your do now, and so let's quickly go over a few of these questions. And so if we take a look at number one, which expression is equivalent to b squared all raised to the 1/3 power? Well, we talked about what on earth do we do when we have this fractional exponent of 1/3 yesterday, and we had that really nice flowchart of, well, we know that the base is going to turn into our radicand. Our denominator is going to end up turning into our index, and then our numerator is going to end up turning into our power. Now, if you take a look though, this is already separated for us, and so we don't really have to worry about our numerator. Our numerator is already 1, which means we can simply just take the denominator and the base and change it into the index and the radicand. And so we set up our radical. Here we go. Gonna have some sort of radical or root here. The base of this outer power is b squared. Okay, so it's gonna go underneath the radical. Again, that's what the radicand is. And then our denominator is gonna turn into our index. So if we look, our denominator right now, that's that 3 value. And so my index is gonna be 3. And so now it's just a matter of seeing what matches. And so if we look over here, not A, B looks good. Let's double check. Not C, not D. Definitely option B. All right. Now, if we look at number 2, we want to convert the following expression to exponential form. Now, remember that when we made that chart up above, it was really nice because we also talked about the fact that as much as we can go left to right in this chart, we can also go right to left on all of these. And so our power is going to become our numerator, our index is our denominator, and the radicand is going to become our base. And so let's just name each of these right now. Our index is 4. Our power is 5. And our radicand is x. And so I know that my base is the same thing as my radicand. So my base is x. And now I'm going to have it raised to a fractional exponent. And so my power is going to become my numerator. And so I'm going to have 5 over my index, because that's going to turn to my denominators, over 4. And there's our final answer. Going through, if you worked on 3, hopefully just a quick little hit and a quick reminder of our work with the product of powers. We should have gotten 24x to the 3rd. Simply multiplying this 6, that 4, and then adding this 5 with this -2. Now, though, I do want to quickly go over 4. And the reason I want to go over 4 is actually sort of twofold. First off, we have to look at what is being asked of us. And so which of the following represents the value of b? And so in order to properly answer this question, I need to figure out, okay, b equals what? That's really what I'm looking for here. And so remember that if we look inside these parentheses right here, I have not 1, but 2 terms that this 3 needs to get distributed to. And so we're actually going to have 2 cubed m to the 4th times 3. That is a 4. I know my pen doesn't always like to cooperate on 4s, which is going to give us 8, already taken care of. Wonderful. And then m to the 4 times 3. Well, 4 times 3, we know that. 8m to the 12th. And so I don't see 8m to the 12th here, but again, let's just quickly revisit what was the original question. Well, it's what does b equals? And so if this b is just the exponent, then I'm looking for just the exponent, and so therefore b is going to be equal to 12, which is option C. All right, feel free to pause the video and get down anything you need to. Once we've got that all down, fantastic. Go ahead, take out notebooks and open up to your table of contents. 10 seconds, go. You can pause the video if you need. All right, so in your table of contents, I would like you to please add 5.06, and we are going to have the wonderful header of simplifying rational expressions. So again, simplifying rational, forgot the A and the L here, expressions. And so in order to talk about radical and sort of to the extent that we saw yesterday, exponential expressions, we need to remember a few things, and these are things we just have to keep in mind as we continue to work with powers. And so the first one is what we really learned yesterday, and even sort of made that chart about up top. If I have x to the m over n, this is really the nth root of x to the m So again, denominator, index, numerator, power, base, radicand. 2, we also want to be comfortable with the fact that we can, as we saw a little bit yesterday, change the order of this. And so what I mean by that is the nth root of x to the m is in fact equal and the same thing as the nth root of x all raised to the m. I can take this m and I can move it outside of the radical. Totally fair game. The reason for that, again, if we're thinking of breaking this into multiplication, breaking that fraction into multiplication, it's commutative, so I can do either one first. For now, just make sure that we've got that. And 3 is really just a general reminder for us to hopefully make sure that we are reducing and or limiting the amount of potential mistakes that we might be walking into. And so when we talk about 2x cubed, we need to remember that this is absolutely not the same thing as 2x cubed. I know they sound the same when I say them. However, 2x all cubed is incredibly different than just 2 times x cubed. Remember, the reason for that is the distribution of this power right here needs to happen to each of those terms. So we saw it in the do now. We're again just going to name it and stamp it and write it so that we are hopefully doing our best to avoid this potential error. And so now let's get into really just sort of like the meat and potatoes of what you're going to be looking at today. And so we actually just jump right in with an example. And so example 1, we want to rewrite the following from exponential. Oh, sorry, not exponential. We want to rewrite the following from radical to exponential. And so what we're going to be looking at here is the square root of x to the 10th. Now remember, when we have a square root, we stamped this in our notes yesterday, when we have a square root, we don't really write the index, but it is a 2. And so the first step I'm going to do if I'm seeing a problem like this is immediately putting a 2 in this index, because if I know that I need to end in exponential form, I know right away that I'm going to end up with some sort of fraction at some point. If I have a fraction, I need a numerator and I need a denominator. I'm going to write the 2 to make sure I'm not missing my index so that I can create that fraction. And so from here, I'm actually going to jump right into the fraction form of that square root. And so by that I mean this is really x to the 10th raised to the 1/2 power. And so here we actually want to remember that we have a power raised to a power, and so I can actually just multiply these two. And so I'm going to have x to the 10th times 1/2. Well, it's going to be x to the 10 over 2. Well, 10 over 2, that's actually divisible. And so I'm going to simplify that to x to the 5th. And so when we go back here, the square root of x to the 10th, well, it's really just 1/2 times whatever power we have, which is going to leave us with 5. Okay, let's look at one more example that has a little bit more going on. And so example 2, we want to do that same thing where we're going to end up rewriting it. I'm just going to put a dashed line just so I don't accidentally write into my previous work. But this time we're going to have the square root of 16 x to the 4th, y to the 6th. And so again, if I'm coming up on a problem like this, my immediate thinking is that I need to get this radical out of there for 2 reasons. 1, so I can actually see what's happening with my exponents, and 2, because I need to rewrite it as exponential form, which means I have to get the radical out of there anyway. And so, first step is remembering that the invisible index here is 2. So I'm naming that right away because it's going to make it more clear that if I remove this radical, I'm going to have 16x to the 4th, y to the 6th, all now raised to the 1/2. Now, we made that statement up above. When we listed those 3 things out that we needed to remember, that third one is going to come in handy. I have 3 terms in here. 1, 2, 3. This 1/2 needs to be distributed to each of these terms. So I'm going to annotate that right now. And this is going to be equal to 16 to the 1/2 times x to the 4th to the 1/2 times y to the 6th to the 1/2. And so now I can apply the 1/2s on the 16, and then I can actually apply my power to powers property on the x and the y. And so this here is going to give me the square root of 16, right? It seems like we're kind of going back and forwards, or back and forth really, with this square root. The reason for that is because we need to be able to deal with the actual exponents and the number. And so in order to do that, we got to change it to 1/2 and then change it back. And so we have this square root of 16 times x to the, well, let's multiply these, 4 over 2 times y to the, again, let's multiply these, 6 over 2. Well, again, if you look at the exponents on our powers, those are divisible. We can actually do that division, and so we absolutely want to. And so, I'm going to take this one step further. Remember that the square root of 16 is going to be 4. Reason for that being 4 times 4 is equal to 16. That's where this is coming in. And then we have x to the 4 divided by 2, that's 2. Y to the 6 divided by 2, that's 3. And so I want you to take like 30 seconds and just list out some of the steps that you saw me take in order to actually simplify these 2 expressions. Go ahead and pause the video if you need. All right, and so if we're now sort of thinking about those steps, let's figure out one of the things I did. And so if any of the steps that you have that I'm about to name, I want you to put a big check mark next to them because they're really important. And if I name any that you don't have, just make sure we write them in. And so first thing I did was confirm our index. And so what I meant by that, or what I mean by that, is I wrote it in, right? Each time I wrote that 2 in there. I'm just going to circle it. And up here, I wrote that 2 in right there. Weren't originally there, but I needed to write them because I know that if I need to make this fraction, I got to know what that is. Step 2, which is really sort of my first step of math, change our radical to an exponent. Got to change that radical to an exponent. And from there, step 3, distribute. I'm going to be more specific, outer exponent, right? We took that 1/2 right here, and we made sure that it went into each of these 3 terms. And then 4, sort of a blanket statement really, but I'm just going to say simplify. Right? We use power to a power right up here, so power to a power, or power of a power right here, which is what let us then get to actual fractions that we could reduce. The only other piece that we had to actually simplify was our square root. And so go ahead and pause the video if there's anything else that you need to get down. And now we're going to jump into some practice to try this out on our own. And so we're going to start with problem set A. And problem set A is all going to be incredibly similar to example 1. And so let's right now put this at the top of our paper that if we are getting lost or have questions, we're going to refer to example 1. Go ahead and start that right at the top of problem set A because it is going to be a very similar piece. Refer to example 1. And so inside of problem set A, I would like you to please do number 1, number 2, and number 3. You're going to work silent and solo. Going to have 3 minutes. I think these are very doable in 3 minutes. Your time starts now. Go. You can pause the video here. All right, so it's been 3 minutes. You've had some time to work on this. I'm hoping that these went a little faster. We're only looking at 1 term. And so, again, if we're thinking back to that checklist that we had in our notes, the first thing I'm going to do in number 1, write in that 2. It's not there. I need it to be there so I can visually see what's going to be happening with our fraction. And so, again, step 2 now, just following that list, rewrite this radical as a fractional exponent. And so I'm going to have x to the 8th all to the 1/2. From here, I'm going to use that power to a power, x to the 8 times 1/2. Remember that multiplying by 1/2 is the same thing as dividing by 2. And so 8 times 1/2, or 8 divided by 2, well, that's simply going to be x to the 4th. Clean that up so it doesn't look like a 9. 4th. There we are. And so there is number 1. Number 2, and to an extent even number 3, the indexes are already there. Sorry, the indices are already named for us. And so I don't have to write anything in. So I get to jump right into step 2, rewriting this as a fraction, z to the 15th to the 1/3 power. Again, applying power of a power, 15 times 1/3. Remember that 15 times 1/3 is the same thing as 15 divided by 3. And so we're going to end up with z. I'm going to write in this extra step just so it's really clear. It's the 15/3, z to the 5th. As we go, I am okay with this step starting to disappear as long as we are ending up with this correct end value. Number 3, again, index is already there. To rewrite this, this is going to be x to the 8th, all raised to the 1/4. Apply power to a power, x to the 8 times 1/4. It's going to be x to the 8/4. Again, let's just make sure that we can see that really easily. It's going to be, well, 8 divided by 4, x squared. And so by now you're probably picking up on the pattern, right? That when we only have 1 term, we're actually just taking the power and just dividing it by the index. And so if I take a look at number 5 right now, I know I didn't specifically ask you to do 5, but let's take a look at it. If I'm going to just use sort of the pattern I'm seeing, my power is 21. 21 over 3 is going to be 7. And so this absolutely should reduce to, I wrote that in the wrong order, there we go, equals x to the 7th. C. All right, again, feel free to either rewind, go back, pause, whatever you need to do to make sure that you've got all these answers down. Once you do, go ahead and go to problem set B. All right. In problem set B, I would like you to please work on number 1 and number 3. Now, really quick in number 3, small typo here that I'm seeing in the packet, and so apologies I didn't catch this sooner. Just make sure we know that this is going to be the square root of 9x to the 10th, y to the 8th. That's 8 should be an exponent. You're going to have, I think again, 3 minutes for these now 2 problems. Again, please work silent and solo. Your time starts now. Go ahead and pause the video if you'd like. All right. So let's take a look at number 1. If the cubed root of x to the 4th is equal to x to the b, which of the following represents the value of b? Okay, I want to focus in, again, really similar in the do now. What is this actually asking us? We need to figure out what represents the value of b, and so in order to do that, we're really being asked, hey, what is b equal when this is rewritten as a single base with a single exponent? And so we need to take this radical form, change it into exponential form, and then name what that power is. And so if we have the cubed root of x to the 4th, well, to remember, right, per what we wrote in our notebook in step 1, this is simply going to be x as the base with the power as the numerator and our index as our denominator. And so our power should be x to the 4 thirds. And so our b value should be 4 over 3 right there. If you had option D, you were really close. The only thing we want to be really sure of is that our index, the number outside, sort of in that corner of the radical, is the denominator, is not the numerator. Our power is the numerator. All right, now let's take a look at number 3. Now, number 3 is really looking similar to example 2. This looks very similar to example 2. And so, again, working off that checklist that we wrote, first thing I'm doing is naming what my index is. It's not written. I'm going to put a 2 and be abundantly clear. From here, I got to rewrite this radical as a power. And so I'm going to have 9x to the 10th, y to the 8th, all raised to the 1/2 power, because again, index becomes my denominator. I'm going to take this, distribute this in, 9 to the 1/2 times x to the 10th to the 1/2 times y to the 8th to the 1/2. Now, you heard me mention this yesterday, and I apologize for not mentioning it earlier in the notes. Our line by line is going to be a big part of what makes us very successful in using these properties and simplifying radical expressions. If we are not neatly writing and neatly using line by line, we are going to be hurting ourselves down the road by potentially mixing up numbers. So just make sure it's really clear what's being raised to what power when we're writing these down. And so again, going through and simplifying, I get to apply this 1/2. All right, that's the square root of 9. Times, I now get to use power to a power, 10 over 2, right? Just multiplying 10 times 1/2 times y to the 8 over 2. Again, multiplying 8 and 1/2. Square root of 9, that's going to be 3. X, 10 divided by 2 to the 5th. Y, 8 divided by 2 to the 4th. And that is our ending expression. All right, as always, if you need to catch anything, go ahead and pause the video. Once we've hopefully gotten everything, go ahead and go to your exit ticket. You're gonna have the rest of class to work on this silent and solo. I do want to see all 3 questions completed. If you finish your exit ticket and still have time in class, a great use of your time would be to study for the quiz that you have tomorrow. Have a wonderful day, and I will see you Friday for your quiz.